For this year's Halloween episode, we are giving out treats. So I am joined by Dr. Ken Lacovara, one of my favorite scientists, and the paleontologist who just so happens to have discovered the world's largest dinosaur, the Dreadnoughtus. I will never get tired of saying that, just FYI. In addition to that, he's also a professor of paleontology and geology and the founding dean of the School of Earth and Environment at Rowan University. In his free time, I happen to know he's a whiz on the jazz drums, and he's been particularly busy with founding the Edelman Fossil Park in New Jersey. I'm super excited to talk to him, and I'd like to start by asking you, Ken, why dinosaurs? I mean, lots of us have a dinosaur phase, but we don't all go on to become Dr. Ellie Sattler in Jurassic Park.
Well, it's true. And hey, Jess, it's great to be here with you. I think all kids do go through a dinosaur phase. And then, some of us have arrested development and actually turn into paleontologists. But no, dinosaurs were these amazing creatures. They're not the funny haha dinosaurs that are so often portrayed in the media, but just these amazing paragons of success and survival that achieved many things that human engineers still can't achieve today. And so in biology, it's always instructive to look at end members, the fastest, the slowest, the oldest, the most short-lived. And dinosaurs are an end member, some of them, for terrestrial environments. And so that's very interesting. But I also think that we can learn a lot from both their success and from their demise and apply that lesson going forward. I think, I always say if you learn to speak the language of the rocks, which you have, the rocks, they start to whisper back to you and they start to tell you things like it didn't have to be this way. It didn't have to be this particular way, right? I mean, at any point in history, there are an infinite number of futures ahead of us, but we only get one past, right? And so all those futures get winnowed down into that single past that we've experienced. And if you really want to understand the future, well, you don't have access to it, right? I mean, nobody can do experiments in the future. Nobody remembers the future. The present is nothing, right? The sentence I am speaking now is already in your past. So what does that leave us with? It leaves us with only the past. 100% of our data comes from the past. And it was Winston Churchill who said, the further back you look, the further ahead you can see. So if you're concerned about the climate crisis, if you're concerned about the biodiversity crisis, if you want to know what the world is spiraling into right now, well, we have some answers for you, and those answers can be found in the ancient past.
Okay, so I love it. I love that you started big. Again, this is the kind of conversation that it gets me out of bed in the morning, and so I do want to nerd out about dinosaurs for a bit because I don't usually, we don't usually see too many dinosaur remains near volcanoes, so right. I don't get to see them in person in the field too often. So tell us about how one goes about discovering a new species like Dreadnoughtus or Paralititan from Egypt. How do you know where to look? How do you know when you've found a new species? And how do you even begin to excavate something that's 85 feet long?
Well, as far as prospecting for dinosaurs, we all use the same formula. You find rocks of the right age, depending on what you are interested in. So I'm not going to look for dinosaurs in the Cambrian period. They were still hundreds of millions of years from evolving. And those rocks have to be sedimentary rocks so that a fossil can form. You can't have a dinosaur fossil in a volcanic deposit, which is why I never get to go to amazing tropical islands. So you have to have sedimentary rocks, and then layers of those rocks have to be exposed. And so that usually means that you'll find us working in badlands environments, places like Patagonia and the Gobi Desert and Montana and Wyoming and Utah, because in a badlands, it's not a total desert. And I have worked in deserts, but you get enough rain to cause erosion, and erosion is a two-edged sword, right? It's really the paleontologist's best friend, but it's also the destroyer of fossils. So you get enough rain to always expose new surfaces, but not so much rain that those pesky plants are covering up the rocks, right? And so every time you go back to a field site in a badlands terrain, there's new surfaces exposed, and you simply get yourself on the ground. It doesn't pay to dig a hole and hope you'll find a bone. The chances of that are pretty slim, although it did happen to me once. You get yourself on the ground and you walk until you see a bone sticking out of the rock. And then if you're interested in finding new species, well, then you got to go to places that people really haven't been before, where paleontologists haven't been. And today, that really means you have to go to places where previous paleontologists were not willing to go. So you have to go to the beautiful but harsh places in the world. And that's how I found myself in the Gobi Desert, or in the town in the world that's furthest from an ocean in Western China, or in the Badlands of Patagonia, or in the Sahara Desert. You have to go to places that are relatively unexplored if you want to have a good chance at discovering a new species. And then, the way you excavate is, I get teased sometimes as a paleontologist because I excavate more like an archaeologist, in that I set up a 1 meter grid and I keep the floors flat and the walls at right angles, and I excavate very, very methodically. And I do that because if you're excavating in an ordered environment, I think it's easier for you to anticipate what is going on in the rocks where you can't see. It's easier to understand like the patterns that you're seeing as the bones emerge, and I just think it's better. And I also spend as much time on the sediment as I do on the bones, because the context is everything. If you're a trophy hunter, if you're a commercial fossil collector, you might just pry the bones out of the ground and put them in the back of the truck, and you're off, and you've got what you want. That's not what we do. We're not trophy hunters. We want to understand how these creatures lived. We want to understand the environments in which they lived, and how they affected the environments, and how the environments affected them. Well, that story is told in the sedimentary deposits. So you have to spend your time working through the sediments, mapping everything. I will collect every clamshell, every oyster shell, every snail. It doesn't matter to me whether it's a dinosaur or not. I'm not a dinosaur chauvinist, right? I mean, they're all equally important, and they all have a story to tell. So you collect this rich data set. And then when you get that material back into your lab, the way you define whether something is or is not a new species, and we really say taxon. Taxon is a more encompassing term for a unique group of animals. So in dinosaur paleontology, we usually work at the genus level. So it's very rare that you name just a new species. You almost always name a new genus and species. So that's the taxon, the genus and species. We can't use the biological species concept like I'm sure all your listeners learned in high school, which is, a species is a group of reproductively isolated organisms that can produce viable offspring. Well, we don't know that for fossil organisms. We don't know about their genetic isolation. We don't know who could do it with who. We don't know who was successful at breeding. So really what we look for is, could a competent paleontologist create a description of a new species that later on another competent paleontologist could recognize? And the way we do that is we look for novel features in the bones. We call those autapomorphies. And you only need one autapomorphy to stand up a new species. More is better. I probably would not define a taxon based on a single autapomorphy, although it happens. But you look for some novel features in the bone that have never been seen in that group of dinosaurs before, and that will allow future paleontologists, if they discover the same kind of creature, they can look at those novel features in the bone and say, it's one of those. I understand how to identify that.
And I think a way to make that stick for folks, at least, especially not being able to tell if something is truly a new species because of the genetic isolation, is maybe looking at horses, donkeys, and zebras,
Right.
because they're all equids and they can interbreed.
That's right.
And you wouldn't, if you just saw a fossil, you wouldn't know if it could or couldn't interbreed. That's what I'm assuming. Does that make sense?
That's completely true. And
Okay.
I would guess if we had omniscience, right, if we could just know everything about the past world, that a double-digit percentage of our species would collapse into themselves. We have probably defined more species than are represented by the fossils that we found. Because I mean, just think about the the body type variation within human beings, right? And so, if you were to find, an athlete who was a jockey and an athlete who was a basketball player, but you find their skeletons in the fossil record, and you can see they're both mature individuals, are you going to name those as separate taxa? Possibly,
Yeah.
right? And
Right.
then
Yeah. Oh,
sometimes
that's
we
amazing.
sometimes separately defined dinosaur taxa will get collapsed into themselves. Like Pachycephalosaurus is a pretty well-known dinosaur. There was another dinosaur defined later on called Dracorex hogwartsii. What do you think?
Wow.
Um, but now it looks like that's probably just a juvenile form of Pachycephalosaurus. And when that happens, the oldest defined name is the one that has priority. So the other name gets collapsed into it then.
Okay, and what I love about this is that, like most science, paleontology is constantly evolving and changing as we learn more and as new technology is available. So, what kind of changes have you seen in the field of paleontology that are driven by new technologies just in the last few decades?
I would say that's a two-part answer. The first part is, how has it changed in the field as an outside? And the answer is very, very little. We don't have any remote sensing techniques to discover dinosaur bones. People try, and it really doesn't work. And the best way to find fossils is still to get your boots on the ground and cover terrain and get yourself in that right condition where you're going to find fossils, and to have a good set of eyes. And you have to train yourself to have a search image. I one time down in Patagonia, um, I've been working down there for a couple years at this point, and there was an archaeologist who was working, I don't know, maybe 100 kilometers away. But I visited her site. We became friends, and she needed some geological work done there. So I came in for a couple of days, and I took off a stratigraphic section for her. And then in return, she was going to come to our site and spend a few days working with us. And she gets there, and now she's an archaeologist, so she's not used to looking for fossils. And she's standing on bones. She's walking across bones. She's not noticing bones. She doesn't have an eye for it at all. And I thought, well, this is going to be a long 3 days. And then she picks up this rock and she shows it to me. And I was like, congratulations, you found a rock. And then she has this smile on her face, like this knowing grin. And I looked more closely at it, and it was a Native American hand axe that was lying in this gully that I had walked by probably 300 times and never noticed because I don't have an eye for archaeological remains. She found that. The next day she found another one, and when she left, we never found one again. So it's about having the search image. I mean, she will see archaeological remains everywhere she goes, and I won't. I will see fossils wherever I go because I've trained my mind to recognize those shapes and patterns.
Yeah, makes sense. So the good old brain, that
Yeah,
still
right.
comes in
So that's
handy. Yeah.
outdoors. So indoors, everything is different. So now we're using all kinds of technology. I was working with a student yesterday who was using advanced medical modeling software to model the joints of giant dinosaurs. He was working on an elbow joint of a giant sauropod dinosaur, and he can input the moments into it, the forces into it, and the model will behave accordingly. And you add some tendons and cartilage in there, and so we're really starting to to understand a lot more about their biomechanics. And then the part of paleontology that I think is most exciting right now is a relatively new field called molecular paleontology. And this was really founded by a friend and colleague of mine, Mary Schweitzer at the University of North Carolina. I'm sorry, North Carolina State University. She would kill me for that. North Carolina State. Um, and she began demineralizing dinosaur bones, which sounds like a terrible thing to do, but you take just a little, maybe cubic centimeter of bone that you cut out and you demineralize it in an acid called EDTA. And and what remains most of the time are original organic constituents from that dinosaur. And people never thought this was possible. And they never did the experiment because they never thought it was possible, right? The answer would be, well, there's a reason why we have refrigerators. Of course that can't happen. And, that's an argument from authority, right? Which is not a good or valid logical argument. So when she started doing the experiment, she started to recover blood vessels and probably blood cells and proteins like collagen from dinosaurs. And now we do this routinely in my lab. We used to call it extraordinary preservation. Now we can recover ancient dinosaur biomolecules pretty much at will. I don't think it's extraordinary preservation anymore. We don't really understand how they are preserved for so long. We kind of have two working hypotheses. One is that perhaps metals in the groundwater are cross-linking the proteins, which are then making those tissues either unrecognizable or undigestible to microbes, or, and this is a and or there may be certain what we call autolithifying bacteria that consume flesh and excrete minerals. They essentially poop out rock. And we think that it's possible that they are cocooning bits of tissue in these structures that they secrete as they're eating tissue. And we call this microbial masonry. So it could be either of those or both of those. We don't fully understand the process. If you asked me 20 years ago to explain the process of fossilization, I would have done it with great surety, because us scientists, us geologists, thought that we knew exactly how fossilization happened. And now, 25 years later, we're not exactly so sure how that happened. So we're working on it.
That's amazing. I think one of the things I love most about anything related to the geologic sciences is how we are still updating our understanding all the time. And it makes me want to ask about your new museum, right? Because I've been following its construction since you first told me about it, and it looks like you're getting close to opening day. So why is there a fossil park in New Jersey? And what was the genesis behind this effort in this most exotic of locations?
Well, I would wager that most people listening do not realize that the world's first nearly complete dinosaur skeleton was discovered in 1858 in Haddonfield, New Jersey, in southern New Jersey. Dinosaurs are first recognized before that from very scrappy remains in Britain. And they get that name dinosaur in 1841 because an anatomist, Sir Richard Owens, can't really tell what they are, because through no fault of his own, his specimens are just too poor to be able to see what they really are. So he thinks they're giant lizards. He writes that it's a tribe of crocodile lizards. So he just thinks these are big puffed up lizards running around on the landscape. That's 1841. In 1858, a nearly complete duckbill dinosaur skeleton is found in New Jersey. And that one skeleton revolutionized our view of dinosaurs. And then, of course, the most famous dinosaur, it's not even close, right, is T-Rex. T-Rex is a tyrannosaur. There's a family of tyrannosaurs called the Tyrannosaurides. And T-Rex isn't the only one. There's about 25 species of tyrannosaurs. And the first tyrannosaur found wasn't T-Rex. That was published in 1905. The first one discovered was one called Dryptosaurus, a tyrannosaur found in Mantua Township in southern New Jersey in 1866. So world's first nearly complete dinosaur, world's first tyrannosaur found there. And these are Cretaceous marine deposits. And they used to be mined up and down the East Coast, where they occurred for fertilizer. It's what farmers call marl. And marl, as in there are towns called Marlton or Marl Pit
Marlton,
or
yep.
Marl Pit, right? Um, and so every farmer that lived on the Cretaceous green sand would dig their own fertilizer pit, their own marl pit. And this was sort of a golden age of fossil discovery on the East Coast. And anatomists from all over the world were flocking to the Eastern US. We didn't really have the term paleontologist at that point. Um, and then in the early 20th century, the Bosch-Haber process was invented, which is a way to artificially fix nitrogen, to create artificial fertilizer. And it became less expensive to go down to your general store and buy a bag of fertilizer than to dig it out of your own pit. And pretty much all those marl pits on the East Coast, thousands of them were abandoned. They're all below the water table, so they all became lakes. That's why in the East, so many municipal parks are a series of, a half a dozen little ponds. Except for this one quarry. It was owned by a chemist named Churchill Hungerford. And in 1926, he started a process where he would bind manganese to the green sand because he realized that turned it into a really good water filtration medium, kind of like carbon is. It's very hungry as far as the ions going by, and it just grabs whatever is in the water. So they ran with that business from 1926 until 2015. The result was they had created this giant Marl Pit in what is Mantua Township, and lots of fossils had occurred there. And I started working there in 2003, just really because it was close to where I was teaching and I could bring my students there. I didn't think much of it in terms of research. So I'd bring my students there so they could get some experience collecting fossils, and then I would just go all over the world doing my own research. And then in 2007, the company started to go belly up, and they announced that they probably weren't going to be in business for too much longer. And they had a closeout plan, which was to fill in the quarry and build a big box store there, it was going to be a Costco, I think. And so my first response was, well, I'll just dig faster. And that probably wasn't the most sensible response. And I realized eventually that's not really a long-term solution. So I thought, well, it would be a shame to lose this site. And I marched into the township office and I found a woman named Michelle Bruner, who's the head of economic development there. And I asked her if she knew what they had in their town there, and she didn't. And I said, well, take a ride with me. And we went over and we took a look. And I told her, I'd like to find a way to save this property. And she really engaged. She became my partner in this very, very unlikely project. And then we decided we're going to find a way to save this property. So, as paleontologists usually try to keep our sites a secret for obvious reasons. And I thought, well, I'm going to have to build a grassroots effort here. So we'll have a community dig day. We have this one layer, it's a bone bed at the bottom of the quarry, and we protect and curate those fossils very carefully. But above that, there's lots of fossils that are a good place for the public to collect. So we have no budget. We put a sign on the road. We send out some emails. I'm hoping on a Saturday, maybe we get 75 people. Well, 1,600 people showed up. And we were not ready. And it was kind of scary. And it was like that scene in Fantasia where the brooms keep multiplying. And like they just kept coming and coming and coming. And it was crazy. But that was a revelation for me, this thirst that the public has for these authentic scientific experiences, for actual legitimate hands-on discovery. And then in the years following that, we got very good at these events. And in the last one that we had before COVID and before construction, we sent out the email for registration. The 2,000 spots filled up in 15 minutes. And we had 9,000 people on the waiting list. And we have 600 schools on the waiting list right now. And so, that was proof of concept that, yes, we needed to save this site and we needed to raise money to build a museum there. That was what precipitated my move to Rowan University, which is almost 10 years ago now. And I moved there, became the founding dean of the School of Earth and Environment and the founding executive director of the Fossil Park. And two alumni, Gene and Rick Edelman, stepped up and made an astounding contribution of $25 million to the project, which got us going in a very strong way. And now, in just a few months, probably at the end of this winter, we will be opening up a $75 million, 44,000 square foot state of the art museum that overlooks this quarry that will have, I think, exhibits the likes of which people have never seen. And it's really also, I think, an architectural marvel. And what we've learned about the site is that research layer that we have been working on for a long time, well, that turns out to be the KPG, or the Cretaceous Paleogene boundary. And that's the moment in time where an asteroid hits the Earth, wipes out the dinosaurs and 75% of species. And that layer has been found in 350 spots around the world, but mostly from just the fallout from the impact crater. Only a few spots have turned up, just scant remains, just a mosasaur vertebra and a tooth in Poland. The same thing in Missouri, weirdly. Some fish scales in Belgium, and a pile of paddlefish and a single dinosaur leg in North Dakota, which tells you it was a bad day for paddlefish, right? At the fossil park site in the last 15 years, from this layer, with the fallout in the layer, we have collected over 100,000 fossils representing over 100 species, all of them literal victims of the asteroid strike, all of them participants in that pivotal calamitous moment that wipes out the dinosaurs and really makes the modern world as we know it. So this place just has so much going for it in terms of science, but also in terms of public education, in terms of community building and sustainability. And we're just thrilled about it, and we cannot wait to open the doors.
I am dying to come and see it. So next time I go to the East Coast, it's happening.
Absolutely.
And
Yeah,
so you kind of teased it there with your last answer. I want to get to the scary part of the conversation. I mean, this is our Halloween episode. So since you study creatures that have suffered extinctions, tell us a bit about some of the changes that can cause species to go extinct. Now, obviously, an asteroid is one. What are some other things that can push species out of existence?
Sure. Yeah. So if you want to be scared on Halloween, think about meteorites. They're very, very scary. Asteroids will kill you for sure. Um, if you want, I can go through the events that unfolded after that asteroid strike, which
Oh, yes.
are
Give us the breakdown.
really scary. So I've been working with some scientists at the Southwest Research Institute. They're in cahoots with NASA, basically, some very smart people. And we've been working out the timing of the events that unfolded after the Chicxulub impact, that's off the coast of Mexico, but with respect to the location of the fossil park in New Jersey. And so if you were there in the waters off the coast of New Jersey 66 million years ago, the day that asteroid hit, you wouldn't have seen it coming in. It did come in from the northeast at about 50 degrees, but you wouldn't have seen it from where you were. You wouldn't have known at the moment of impact because the big flash would be way over the horizon. But about 8.5 minutes later, a magnitude 10.3 earthquake would roll through the area. And I'm sure you know that the Earth can't make a magnitude 10.3 earthquake. Rocks don't have enough strength to build up to make an earthquake that big. So you have to ring the Earth like a bell from the outside in order to do it. And then the most deadly moment occurs about 17 minutes later, which is that all that rock, it's an area, the crater was about 110 miles across by 12 miles deep. So that's roughly Massachusetts. So I don't know if anybody's ever weighed Massachusetts, but I imagine it's pretty heavy, right? So pulverize Massachusetts, throw it up through the atmosphere. You've given it a tremendous amount of potential gravitational energy. When that stuff comes back in, even though it's only a millimeter, at a time, it's got the same mass. It's got to balance the energy books. How does it do that? By friction with the atmosphere. If you think back to those scenes of the Apollo space capsules flaming back into the atmosphere, imagine that day, trillions upon trillions of millimeter-sized space capsules, each one flaming back into the atmosphere, each one heating up a little parcel of air around itself. And the result that day globally is that temperatures probably got up to somewhere between toaster oven and pizza oven. So if you don't have a place to hide that day, you are gone. And all of the non-avian dinosaurs, the dinosaurs that aren't birds, that we know about, were all ground nesters. A mama dinosaur would just scrape a crater in the surface of the earth, deposit her eggs right on top. So 100% of their life cycle on the surface of the continents, no place to hide. I think they're functionally extinct within an hour after this event. If you're small and you can burrow, like our ancestors, little burrowing shrew-like mammals, turtles, crocodiles, little lizards, things like that, you have a chance of surviving that day. If you're in the ocean, you're fine. In fact, you probably do well after that because all this barbecued dinosaur meat gets washed out to sea, and the mosasaurs are having a barbecue party for a while. But pretty soon, all that dust and gas in the atmosphere shrouds out the sun, kicks out the base of the marine food web, which is the phytoplankton. The food chain is very short in the ocean, like 2 or 3 weeks. So within a couple of weeks, pretty soon there's nothing for the big creatures like mosasaurs to eat, and they begin to starve. So we have two parallel mass extinctions, one because of the asteroid impact, one because of starvation. And the result is we lose 75% of species on the planet. That's the world's fifth mass extinction. And we know now from geology and paleontology that the previous four mass extinctions were all driven by climate crises. And I would say the fifth one was a climate crisis itself. It was an instant climate crisis induced by an asteroid impact. So we know now from geology that the climate can and will kill you, right? And so what are we doing
Yes.
now? If you want to be
Yeah.
scared on Halloween, think about that. And so, if you go back 300,000 years ago to the emergence of our species, Homo sapiens, well, they had about the same brain size we do, possibly even a little larger. Well, why weren't they building towns? Why weren't they, writing books? Why weren't they doing so many of the things that we do? They had our brains. Well, they couldn't because the climate wasn't really stable at that point. And the climate during the Pleistocene, had a lot of swings up and down in it. And, they weren't able to do that 300,000 years ago or 100,000 years ago or 50,000 years ago. And then what happened 10,000 years ago? The climate goes into this sort of accidental, very stable condition. And now all of a sudden, people are able to occupy a spot on Earth this year, and then that spot's still okay the next year. And they can plant some crops, and they can maybe harvest those crops, and they can build a little structure, and that structure is still good for the next year, and they can settle down, and civilization starts because we hit this anomalously stable period of climate. And what are we doing now? We're using the atmosphere as a garbage can, ruining the precise thing that led to our civilization. The very thing that made human civilization possible is the very thing that we are destroying right now. And, you pull back to the far side of the moon and look at that Earthrise image that the Apollo 4 astronauts first saw. I mean, we live on this tiny little lonely lifeboat in space, but we don't feel it. We don't feel like it's a little lifeboat in space, but that's exactly what it is. And I guarantee, anybody listening, if you were on a lifeboat with 6 other people in the middle of the Pacific Ocean, you would take damn good care of that lifeboat, right? And you would not be poking holes in the lifeboat. It's no different. It's a much bigger lifeboat, and it's kind of hard to see the whole thing at once, but it's still the only lifeboat we have. And it's all we're ever going to have. We're not going to Mars, Elon Musk. I mean, we're going to explore Mars, and there's going to be an Explorers Club flag on Mars someday.
Oh, yeah.
But we're not going to put 1 million people on Mars. You know why? Because Mars is terrible. Mars is an awful place.
Yes, I've been on the Mars is the worst place to go. Like, I'd rather go to Venus, and that says something because Venus will kill you up front. Like you're just dead.
At least
Mars,
on your way down through the Venusian atmosphere, at some point it's 72 degrees. It's someplace it's nice, right?
It's balmy for about an instant.
Yeah.
But okay. So if there is one thing that I have learned from talking with people involved in preserving pieces of the past and studying our planet, it's that museums and similar knowledge repositories are really valuable for helping us to understand the present and potentially the future. So what inspires you to keep going with your research and with building the museum in the face of continuing human-caused climate change?
Well, It would be very easy, knowing what you know, knowing what I know, to sink into despair, right? And it's actually something I think most scientists have to fight against, because we understand how this stuff works, and the indicators don't look great. However, I think hope is a choice. I would not say that I have empirically derived hope. I think I choose to be hopeful, because what choice have I, really? Right? I'm not going to be nihilistic about it. I'm going to get up every day and I'm going to do what small thing I can to try to make this planet a better place and try to preserve it for our posterity. And, will we succeed? Well, that's an open question, but that doesn't mean we shouldn't try. And so I think it's really incumbent on all of us to find that hardest thing that you can do. And that's different for everybody. If you're a single parent working an extra job, trying to make ends meet, well, maybe that's not a lot, and that's okay. But little things do add up, and you can vote, which is a powerful force. But if you're somebody with education or resources or a network or time, there are things that you could do. And, given the choice, like in a perfect world, I'd probably want to spend every day in some forgotten desert digging up big dumb dinosaurs. But I don't feel like I have that Victorian luxury every day of my life right now, because the world is on fire. There's holes in our lifeboat, and I need to do what I can do to make it better. And, I'm not an engineer. I don't know how to make the next best solar cell or to do many of the things that will solve the problems, but I know what I can do, and I can tell stories. And I can tell stories about the past that relate to the present, that hopefully will help humans plot a better course into the future. And that's the job of museums. That's what museums do. So, and building a big, giant, super complicated museum from scratch is hard, right? So I kind of feel like I have found the hardest thing that I'm capable of doing at this moment. So that's what I'm doing, and I'm doing it, in part because, of course, I love dinosaurs. Carl Sagan said, "When you're in love, you want to tell the world," and that's how I feel about dinosaurs. But I'm also doing it because I have to. This is a 5 alarm fire right now, and I don't feel like I have a choice.
Hear, hear. So we've sort of touched on these topics that I'm about to ask you about a little bit already. But this is our last question. It's a two-parter that I save for everybody here on This Is Science. And you're a scientist, as you mentioned, not an engineer. You're many other things as well, but your primary role is scientist. And we are the Union of Concerned Scientists. Now, I know that you've already told me a little bit about this, but Ken, why are you concerned?
I'm a very concerned scientist. Well, if you look at the temperature curve, if you look at the CO2 curve, I mean, you know what this looks like. It looks like a hockey stick. It goes along this way, and then boom, it looks like a mistake in the chart, but it's not a mistake in the chart. It's the brick wall that we are all facing. And you now cannot find a more dramatic change in Earth systems, except going back 66 million years ago to when that asteroid hit. I mean, you're scaring the geologists. And when you scare the geologists, right, you who have seen everything, it's not good. And the thing that I find even more scary on this Halloween is the biodiversity crisis. And it's not talked about nearly enough. It's not thought about nearly enough. And it's that kind of overlooked existential crisis, which will also kill us if we don't straighten that out as well. It's not enough to solve the climate crisis. We have to solve both if we're going to have the kind of future that we want. And I don't think people really understand in general the depths of it. So we have lost 69% of wildlife since 1970. Not species, but individuals. So if you count the wild animals on Earth in 1970, we've lost 69% of that. That's absolutely shocking. If you go back a couple hundred years, humans and our Livestock account for just a fraction of a percent of the biomass of life on Earth, right? If you just weigh all the organisms, what's the biomass? Well, now humans and our animals account for 96% of the biomass on Earth. All of the wild animals on the continents account for 2%. All of the wild animals in the ocean account for 2%. That's scary and that's concerning. I am a concerned scientist. And so um,
Yeah.
we need to reverse those trends. And so we now have to do the hardest thing that a society has ever done, which is we need to rapidly decarbonize our societies, our economies, and
Yeah.
we need to quickly make space for the natural world. And those two things are not easy. They require change at scale. They are not inherently political. I mean, everybody needs the air and the water and the creatures that provide our ecosystem services. And, hopefully they will stop being thought of that way they are now, which is unfortunate. If you're in that little life raft in the middle of the Pacific Ocean, it's not political whether you're going to fix the leak or not, right? It's everybody understands you got to fix the leak.
It's
Well,
life or death.
our life
I mean,
raft is
look,
just a little bit bigger, and we all need to take care of it and fix it. And that's one of the roles of museums, which is that, kind of the underlying premise of the museum is that people love what they know and people protect what they love, right? And you're not going to protect the planet, you're not going to protect our wildlife if you don't fall in love with it first. And we think we can help people fall in love with this amazing planet that we're unbelievably fortunate enough to be a part of.
and so it sounds like you and your work with the museum and your storytelling are leaving people with their Halloween treat. That's these places, that these spaces, these opportunities for engagement. Sounds like that's how you're addressing that concern. Is that accurate?
I'm doing what I can do, right? Those are the tools that I have in my tool belt, and I'm going to use them as best I can.
Well, I think you're doing a fantastic job, Ken. I appreciate your time. I appreciate your energy and effort, not just for the show, obviously, but for your larger life's work. One person can make a difference, and I think you're living that to its utmost. So, thank you so much for talking with me and sharing a little bit of your passion today.
Thank you, Jess. It's a real pleasure.